Hello everybody, welcome to my channel. This video is about the real numbers. It's an overview of 10th standard first chapter of mathematics. It is what is a real number? A real number set will be set of rationals and irrationals. Rationals I have given the example here, irrationals I have given the example here. What are rationals? They are written in the form of p by q, where q is not equal to 0. What about the irrational numbers? They are non-recurring, non-terminating numbers. So I have given the example here. They are irrational numbers. Now we have Euclid division lemma in this chapter, which will tell about, it is stated in theorem 1.1, which tells that given positive integers a and b, there exists unique integer q and r satisfying a is equal to bq plus r, where q is nothing but the quotient and r is nothing but the remainder. So let us take the example 17 and 6. If we divide 17 with 6, then what happens? 6 2s are 12, then 5 is the remainder, and here 2 is nothing but the quotient. Now let us take 5 and 12. If we divide this 12 with 5, then 5 2s are 12 and 2 is the remainder. Here this 2 is quotient and this 2 is the remainder. So this is about the Euclid's division lemma. Now we will take a look about Euclid's division lemma. It is based on this technique. Actually, this is based on Euclid's division lemma, and this technique is used to find HCF of any two given positive integers. For example, if we take 455 and 42, we have to divide this 455 with 42, and this is 442 tens are, then remainder will be 35. Now this 42 has to be divided with the remainder 35. So 35 ones are 35 and the remainder is 7. And next, dividing this 35 with 7, 7 5s are 35 and the remainder is 0. Therefore, the HCF of 455 and 42 is nothing but 7. This is 7. So this is about the HCF. And with the division lemma, Euclid's division lemma, we can find out the HCF. Let us go for the fundamental theorem of arithmetic, which is 1.2 theorem. Every composite number can be expressed as a product of prime numbers, and these fractions is unique apart from the other apart from the order in which the prime factors occur. So every number, composite number, can be expressed as, let us take the example of 12 here. We can write down this factors, 12's factor as, let me write down it properly. If you take 12 is equal to, I can write 4 3s are, right? And then the prime factor of this 4 is 2 into 2 into 3. So every this is a composite number. If we are able to write down a number as a product of the prime factors, then it is a composite number. So 12 is a composite number, and in the same way 16 is also a composite number, wherein we can write it 16 as 2 power 4. And every composite number is unique because we can see that 16 is 2 power 4, 12 is 2 power 2 into 3. So every composite number is unique. And let us take the example of 32,760. It can be written as multiplying 2 3 times and 3 2 times and 5 then 7 into 13. So that will be 2 cube plus 3 square into 5 into 7 into 13. This is what we get. Now from this Euclid's, as I said, from Euclid's division lemma, we can find out the HCF. So let us take a look about what is HCF. HCF is nothing but the product of smallest power of each common prime factors in the numbers. Let us take the example of this 12. 12 can be written as 2 square into 3. 16 can be written as 2 power 4. Now in these two things, in these two numbers, the smallest power is 2 power 2, and that is the HCF. HCF is nothing but 4 for 12 and 16. Now this is nothing but, this is the method of finding HCF with the prime factorization method. Now what is LCM? LCM is nothing but the product of greatest power of each prime factor involved in the number. So 12 is equal to 2 square into 3, 16 is 2 power 4, same thing I have taken, and they have given that product of greatest power of each prime factor involved. Here in this, the prime factors which are involved are 2 and 3. The greatest one is 2 power 4 out of 2 power 2 and 2 power 4. 2 power 4 is the greatest one. And then the other number which is involved is 3. So if you multiply these two, we'll get 48. So that's the LCM of 12 and 16. Now, not only this, we have to learn even the number which is like, if I take 4 power n, if I take 4 power n, can we get it's in the it may be some number. 4 power n, maybe if I take 4 square, it will be n is n may be equal to 1, 2, 3, etc. If I take 4 square, then it is 16. So is there any possibility of getting in the unit place 0 if we have 4 square or 6 power n or 7 power n, etc. So that also we are going to learn in this chapter. Thank you for watching. In my next video, I am going to cover the numericals of HCF from the real numbers. Thank you once again.